we are going to start with a review of derivatives. So before you can take derivatives of multivariable functions, you have to know how to take derivatives of single variable functions. So we're going to practice with that. And this is going to be just the mechanics of it, so not a whole lot about what the derivative is, although that's real important. The derivative is a slope, it's a rate of change, it's a limit, it's all of those things, but we're just going to be looking at the mechanics of how to take a derivative. So we'll start with what most people remember, and that is a polynomial. So if I have f of x equals 6x to the third plus 2x squared, then the derivative of this, so when you have a polynomial, then you multiply the exponent times the coefficient, and then you subtract from the exponent. So here we get 18x, so you multiply first, then subtract squared, plus 4x, you subtract 2, you get 1. 4x, that's understood. When you have just an x, it's understood to have the exponent 1. All right, so what about if I had, well, let's just use the one that we have right there. Let's take the second derivative, so f double prime of x. So we multiply, 2 times 18 is 36, subtract 1 from the 2, and I get 1. I don't need to write that. Now the 4x, remember there's an understood 1 there. 1 times 4 is 4. When you subtract 1 from 1, you get 0, and anything to the 0 power is just 1. So officially this is 4x to the 0 power, but you don't write that because x to the 0 power is just 1. So what that means is anytime you see something like g of x equals 3x, the derivative of that is just 3. If I had h of x equal the square root of pi times x, square root of pi is just a number, h prime of x equals square root of pi. Okay, well let's take the third derivative of this, f triple prime of x. And remember that x has an understood exponent of 1, so this is 1 times 36, x to the 0 is just 1. Now what about this 4? Well, if you remember, we said that that's kind of like having an x to the 0 right there. And 0 times 4 is just 0. And so the derivative of a constant is always 0. So anytime you have just a number, its derivative is 0. So we would have, if I had f of x equals 5, f prime of x equals 0. G of x equals the square root of 3 over 2. G prime of x equals 0. F of x equals the natural log of 21. That's still just a number. F prime of x is 0. H of x equals 10 to the 4th. That's just a number. H prime of x equals 0. Okay, so I can give you a couple to do. I'll write them on here. You pause it and do them and see if you get them right. So I've got f of x equals negative 6x to the 5th plus 2x, and g of x equals x squared minus 3. So pause it and do these, take the derivative of these and see how you do. Okay, so what you should have gotten is that f prime of x equals negative 30x to the 4th plus 2. 5 times 6 is negative 30. Subtract 1, you get 4. Derivative of 2x is just 2. And g prime of x is 2x, and the derivative of the constant is 0. Okay, so that's polynomials. Then you have things that work like polynomials, although they're not polynomials, but you still use the same rules. So recall that if I have 1 over x to the 5th, that's the same as x to the negative 5th. 1 over x to the 3rd, that's the same as x to the negative 3rd. So anytime you have something in the denominator, you can rewrite that as having a negative exponent. So if I had to take the derivative of f of x equals 3x squared plus 6 over x to the 5th, then the first thing I would do before I take the derivative, I rewrite it 3x squared plus 6x to the negative 5th. So I take that out of the denominator and I write it as something with an exponent. Now that I have it in this format, then I use the same rule that I multiply and subtract 1. So f prime of x equals 6x, negative 5 times 6 is minus 30, x, and then when I subtract 1 from negative 5, I get negative 6. So 6x minus 30x to the negative 6. Okay, so now you do this one. We've got g of x equals 1 over, making this a little tricky, 1 over 2, I'll do this one, and then we'll do one like it, 2x to the 3rd plus 3 over 7x to the 5th plus 2. Okay, so one thing to realize here is that the 2 is not part of the x. I don't bring that to the numerator. So I've got x to the negative 3, but the 1 over 2, that just stays 1/2. Because the 2 is not part of the x. The x to the 3rd, that goes together, and that becomes x to the negative 3, but the 2 is just multiplied by it. So it just stays there. Similarly, this would just be 3/7 x to the negative 5th plus 2. So that's just rewriting it. I haven't taken the derivative yet. G prime of x, now I multiply negative 3 times 1/2, and when you multiply, so negative 3 times 1/2, just multiply the numerators and multiply the denominators. So that's negative 3/2 x, you subtract 1, gets you negative 4. Then if I take 3/7 times negative 5, multiply the numerators, multiply the denominators, and I get minus 15/7 x to the negative 6, and the derivative of a constant is always 0. Okay, so let's try this one. So f of x Okay, so you try this one. F of x equals 7x to the 3rd plus 9 over 6x. Yeah, let's do that. Okay, so you try that one. Okay, so first thing you want to do is rewrite it. 7x to the 3rd plus 9/6 x to the negative 1. So f prime of x, that gets us 21 x squared minus 9/6 x, subtracting 1 from negative 1 is negative 2. And then 9/6 can be simplified. Divide 9 and 6 both by 3, minus 3/2 x to the negative 2. A shortcut thing to remember is very handy. So just like, I'm going to make a separate page for things to memorize. So on this separate page, things to memorize, you can get this by doing what we just did, but the derivative, and this is the symbol for taking the derivative of 1 over x is minus 1 over x squared. And the reason for that was because we had, when we took the derivative of x to the -1, multiply by -1x, subtract 1, x to the -2. So we've been going in one direction, taking things out of the denominator and giving them negative exponents. You can also go in the other direction. This can be -1 over x squared. And just like the in before where I said the 2 didn't go with the x cubed, well, it's just 1, so it could have gone, but we just left the 1 behind there. Okay, so now back to things to memorize. And these could be any numbers, I'm just using an example here. The third root of x squared is the same as writing x to the 2/3. Also, 1 over x to the 5th is the same as writing x to the -5. So fractional exponents the top number is the power and the bottom number is the root, and a negative exponent reciprocates. And by reciprocate, it means if it's in the denominator, it goes to the numerator. If it's in the numerator, it goes to the denominator. So for instance, 1 over x to the -5, that's the same as x to the 5th. So when you move it, you change its sign. So fractional and negative exponents are different, but you can have both of them. So if I had x to the -1/2, that's the same as 1 over x to the 1/2, which is the same as 1 over, the denominator is the root, the square root of x to the 1st power. But generally we don't write the 2 for a square root, and we don't write a 1 for an exponent of 1. Okay, so now let's try f of x equals 3x to the 3rd plus 2 times the 5th root of x to the 3rd plus 9 over x squared plus 1 over the 3rd root of x. Okay, so the first thing we want to do is rewrite this so they're all exponents. That's 3x to the 3rd plus 2x. The exponent is the numerator, the root is the denominator, so x to the 3/5 plus 9. Now the x is in the denominator, so it becomes to the -2. Here we have a root and it's in the denominator, so it'll be negative, And then the exponent is going to be 1/3 because the power is 1 and the root is 3. So now we can take the derivative. 3 times 3 is 9. So this is 9x squared plus 2 times 3/5 is 6/5 x, and then I subtract 1 from 3/5. So subtracting 1 is subtracting 5/5. That's -2/5. So x to the -2/5 minus 18x to the -3 minus 1/3 x. Now I need to subtract 1 from 1/3. So subtracting 1 is subtracting 3/3. So that gets me -4/3. Alright, now you try one. I'll put it up here, pause it, and try it. So g of x equals -7 x to the 4th plus 1 over the square root of x. Oh, I'm going to make this 1 over 5 times the square root of x plus 6 over x to the 3rd plus the 3rd root of x squared. So first we want to rewrite everything as an exponent. This is -7x to the 4th plus, and remember that 5 doesn't go with the x, so it's just 1/5. X is in the denominator, so it'll be negative, and it's a root, and so the power is the numerator. The power is an understood 1. The root is the denominator. It's a square root. That's an understood 2. So it's x. It's negative because it's in the denominator. The root, it's a square root, that's an understood 2. The power is the exponent, that's an understood 1. Plus 6x to the -3 plus x, now the power is the numerator, 2, and the root is the denominator, 2/3. So that's just rewriting it. Now we need to take the derivative. So that'll be -28 x to the 3rd minus 1/5 times 1/2 is 1/10. When you multiply, you just multiply across. So that's -1/10 x. Now I need to subtract 1 from 1/2. So -1/2 minus 1. So -1 is -2/2. So that's -3/2. X to the -3/2. Subtract 1 from -3 is -4 plus 2/3 x. Now I need to subtract 1 from 2/3. Subtracting 1 from 2/3 is subtracting 3/3, and that gets me -1/3, x to the -1/3. Some special functions so that you have to memorize. Here they are. The derivative of sine x is cosine x. The derivative of cosine x is minus sine x. The derivative of tangent x is secant squared x. The derivative of secant x is secant x tangent x. The derivative of cotangent x is minus cosecant squared x. And the derivative of cosecant x is minus cosecant x cotangent x. Nothing to be done about it except to memorize them. They just have to be memorized. I'm sure there are plenty of Quizlets out there that can help you with that. Then we also have the derivative of e to the x is e to the x, and the derivative of the natural log of x is 1 over x. We also have the arc trig functions. I'm not as worried about those right now. You should know the derivatives of arcsine and arctangent. But we'll hold on to that. We'll worry about that another day. Now, we're going to talk about the chain rule. But before we talk about the chain rule, this is the chain rule, but it gives you a shortcut when you have these same functions, but just multiplied by a number. So like, let's say I had sine 3x. Well, the derivative of sine x was cosine x. And so the derivative of sine 3x is cosine 3x times the derivative of 3x, which is just 3. And this is going to be the same pattern that's going to follow for all of these special functions when you just have just one, multiplied by a constant. So the derivative of the tangent of negative 2x will be negative 2, derivative of tangent is secant squared negative 2x. The derivative of e to the 5x is, the derivative of e to the x is e to the x, so the derivative of e to the 5x is 5e to the 5x. And that's going to be the case whenever you have, the only thing here is that you're multiplying by a constant. It's even true, although it's kind of weird the way it works out. If I took the derivative of the natural log of 6x, so the derivative of the natural log of x is 1 over x, so this would be 1 over 6x, but times 6, and those 6's are going to cancel out, and you'll get 1 over x. And so it's always going to be true with natural log. The derivative of natural log, a constant times x, is going to be 1 over x. That's just a interesting thing. Okay, so that was like your brief introduction to the chain rule, but the big thing I wanted to look at was these special functions, and then now we'll see how to use the chain rule in general. So what the chain rule says is if I have f of g of x, so I've got two functions. I've got two different things going on, and I want to take the derivative of it. It's going to equal the derivative of the outside function, leaving the inside function alone, times the derivative of the inside function. So let's see what I mean by that. Let's say I had as my function h of x equals the sine of 5x squared. I've got two functions going on here. I've got sine and I've got 5x squared. The outside function is sine, so I take the derivative of it first. The derivative of sine is cosine, and what you want to do here is don't think, just leave that inside alone. So you're just taking the derivative of the outside. Once you've done that, then you multiply by the derivative of the inside, and the derivative of 5x squared is 10x. So let's say g of x was e to the 4x squared plus 2. So we've got two functions. One function is e to the something, and the other function is this 4x squared plus 2. What was the derivative of e to the x? The derivative of e to the x was just e to the x. So first we take the derivative of our outside function, and that says it's just this, 4x squared plus 2. I don't change it. The derivative of e to the x is itself. But this isn't just x up here, it's another function, so now I have to multiply by the derivative of it, which is 8x. So f of x equaled the sine of the natural log of 3x squared. Got three functions. Start on the outside. What's the derivative of sine? It's cosine. You do that one, you leave everything else alone. Log 3x squared. You're tempted to do more, but don't. Just take the derivative of the outside function. Then you go to the inside function, natural log. What's the derivative of natural log? It's 1 over the thing that's in there. So I do 1 over, and I resist doing anything to it. It's just going to be 1 over 3x squared. But 3x squared is not just x, so now that's a function too, so now I take the derivative of it, and I get 6x. So if I cleaned this up a little bit, which I can't help doing, which is not really the point of this lesson, but 3x squared times 6x over 3x squared. 1x cancels, and the 3 cancels with the 2, and so I get 2 over x cosine natural log 3x squared. Okay, now let's try f of x equals 4x to the third plus 2x plus 1 to the fifth. Okay, this also has an inside function and an outside function. The outside function is raising to the fifth power, and the inside function is this 4x cubed plus 2x plus 1. So how would you take the derivative of x to the fifth? You'd have 5x to the fourth. So we do the same thing here, only we don't change what's on the inside. We leave that alone. That's going to be 4x cubed plus 2x plus 1 to the fourth. Now we multiply by the derivative of the inside, which is 12x squared plus 2, being careful to put it in parentheses because we're multiplying by that whole derivative, not just the 12x squared. If we didn't put it in parentheses, the order of operations would multiply just by 12x squared and then add the 2. Okay, now let's look at a special way that this is sometimes written. Let's say I have g of x equals sine squared of x. That sine squared of x is just a shortcut for sine of x squared. And so that shows us that the outside function is raising to the second power, and the inside function is sine of x. So g prime of x, you multiply by 2, I get 2 sine x, subtract 1 from 2, I get 1, times, now multiply by the inside function, the derivative of sine x is cosine x. Okay, what if I had h of x equals tangent squared of cosine of x. Okay, so I would rewrite this as the tangent of cosine x squared. And then h prime of x is going to be 2 tangent cosine x subtract 1 times the derivative of the inside. Now the inside has two functions to it. So the first thing I do is I take the derivative of tangent. The derivative of tangent is secant squared, but I don't change the cosine x. And now I take the derivative of the inside function again, and I get minus sine x. So in all, I get 2 times the tangent of the cosine of x times the secant squared of the cosine of x times the negative sine of x. Okay, that's the chain rule. I'm going to give you one to try. So one thing I always do is I always rewrite roots as fractional exponents. So before I do any differentiating, rewrite that as x to the third plus 2 to the 1/2. Okay, now remember that squared is an outside function. So f prime of x, well, let's not do that yet. Let's just rewrite it first. This is still f of x. It's a sine of x to the third plus 2 to the 1/2, but that's all squared. So now the outside function is squared, so it's 2 sine x cubed plus 2 to the 1/2. Now times the inside function, so this is the inside function, and that's sine, so the derivative of sine is cosine, and I don't change this, x to the third plus 2 to the 1/2, times, now I take the derivative of the inside of this, which is x to the third to the 1/2, so it's the inside function. Draw this better. So the derivative of sine was cosine. So this cosine, that's already the derivative. And then I leave this alone, x to the third plus 2 to the 1/2. Now I multiply by the inside of this. So the inside of this is going to be 1/2 x to the third plus 2 to the negative 1/2, because I have to subtract 1 from 1/2. 1/2 minus 1 is 1/2 minus 2 over 2 is minus 1/2. And now times the derivative of the inside of that, which is 3x squared. Okay, so that is the chain rule. Now let's review product rule and quotient rule. You don't use the quotient rule that often. You use the product rule fairly often. So if I have two things multiplied together, f times g, the derivative of f times g is f prime g plus fg prime. And the derivative of f over g is f prime g minus fg prime over g squared. So let's say I had e to the x times x squared plus 3. That's a product. Those are two things multiplied together. So f is e to the x, g is x squared plus 3. F prime, the derivative of e to the x is e to the x. G prime, the derivative of x squared plus 3 is 2x. So the derivative of this h prime of x is f prime, which is e to the x, times g, which is x squared plus 3, plus f, which is e to the x, times g prime, which is 2x. Okay, now let's say I had h of x equals the cosine of x squared over 3x squared. So h prime of x, well, let's identify f and g. So f is cosine x squared, g is 3x squared. F prime, the derivative of cosine is minus sine of x squared, but that's not just an x, so I have to use the chain rule, times 2x. G prime, the derivative of 3x squared, is 6x. So h prime of x equals f prime g. So f prime was minus 2x sine x squared. G was 3x squared times 3x squared minus f, which was cosine x squared, times g prime, which was 6x, all over g squared. G was 3x squared, so 3x squared squared. And then cleaning this up a bit, negative 2x times 3x squared is negative 6x to the third, sine x squared minus 6x cosine x squared, all over 9x to the fourth. And there's plenty of places you can find to practice product rule and quotient rule. And I think that's as far as I want to go here. Because you really have to be able to do these things before you can differentiate multiple variable functions. I'm going to pause the recording for a minute and come up with some problems for you to try on your own and see how you do with them. Now, to give credit where credit is due, I did not write these. These came from this nice website where this instructor has these nice worksheet with answers and more practice there. So if you go there, there's good stuff. Make sure this has chain rule in it. Yeah, it does. Okay, and so yeah, you don't do all of these at all, but pick some that you think look interesting and try them and see if you can do them. And then we have the answers here, so you can pause it here, write something down that looks interesting, and then see if you got the right answer. You can fast forward to here where you have answers 1 through 24, and you can pause it and get the answer. Or here we have 25 through 30. And I see there are some on here that I did not do, so just in case you wanted to know, the derivative of a to the x, where that's not e, is the natural log of a times a to the x. So the derivative of 5 to the x is natural log of 5 times 5 to the x. So that's not one I gave you. I also didn't give you arctangent and arcsine, which I said are good ones to know. I'll just go ahead and give them to you now. So the derivative of the arctangent of x is 1 over 1 plus x squared, and the derivative of the arcsine of x is 1 over the square root of 1 minus x squared. You do have to be careful with that one, so let's just do this for fun real quick. Let's say that my function is f of x equals the arctangent of 5x squared. So the derivative of arctangent, I said, was 1 over 1 plus x squared. Well, that's the derivative of arctangent of x. If I wanted to take the derivative of the arctangent of 5x, it would be 1 over 1 plus 5x squared, but then times the chain rule times the derivative of 5x squared is 10x. So this would be 10x over 1 plus 25x to the 4th. Okay, so those are some practice problems if you want to work on those.